what is actually the zero waste level of this piece of cheese? Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And today it is about zero waste mentality, and we'll take a nice example into it, which is this cheese over here. So when, and you know, right, I worked in food, I worked at cheese factories a lot. In fact, I also worked at the one who makes this one. I really like it, but no advertisements here. What is zero waste level when we're going into like a material balance and zero waste calculations, cost deployments, things like that? That term keeps popping up. Right? Now, what they have also done is they put a label on the back saying quite a number of things. So, for instance, they say that this piece is supposed to weigh 500 grams with one of those European estimates on it. So it's roughly 500 grams. Maybe it's a bit lighter, maybe it's a little bit heavier than actually weigh this one, but I know from experience that most of them will be slightly heavier, and sometimes one of them is a bit lighter, but they will be at least 500 grams. That's what we promise. At least. So that's already more than 500 grams, right? But there's more on here. So they have percentages of fat and protein, which are the value components. Like there is water and sugar and stuff like in here, but that's not so valuable. So let's get into what they put on the package. So we get quite a bit of good information on the value drivers of this product, which is sort of mandated by law that they put it on it, although this is more mandated by nutritional type of law. But this is basically your zero material waste. Because what you promise to your consumer, that is what is your basic specification. Now, of course, this company, based on laws and based on what they put on the package, they have also created a formal internal specification, and there is some wiggle room in the fat, there is some wiggle room in the protein, and there are rules around it. But let's simplify it slightly. This, what you promise to the consumer, that is your zero level. So anything over 500 grams is a waste because you didn't promise it to your consumer. They didn't pay for it. They weren't even probably expecting it. They may like the extra slice of cheese, but it is, from our cost deployment point, a waste. And if you go over these percentages, again, that is also a waste. Now, there is a bit of a thing in the cheese world and the dairy world that if you put a bit more fat and a bit less protein, you get the same dry matter, but it's cheap. Okay, details when I get back into that industry. If we go over these two, we are overusing. So that is what we really use to go into our calculations for zero waste. Now, it might be good to also state that the fat and protein, the cheese itself, it's not the only thing, right? So when we looked at this back, you saw a couple of different things. You also saw that there's foil, the shiny thingy, around it. So 12 by 14 and 4. And so there is a whole bunch of foil around it. Now, there's a couple of labels on there. So that is the basic zero loss level. If we want to make this cheese and sell it, we need to have 500 grams of cheese. We need to have so much fat and protein. And there should be some foil and free labels on there. Now, we know, of course, that in production, we'll probably use a bit more foil because we wrap it around and then cut some parts away around it to fit it nicely around the form of our product. It's a waste, it's scrap. Okay, that happens, but the zero loss level is what is on the product. The same with the labels. Now, labels are a very distinct thing, right? So you either scrap a label or not. Here you can use 380 or 400 on average. Labels, you either stick on one label or two, or in this case, you either stick on those 3 specific labels, or you mess it up and you use more of them. But still, 3 labels times the number of products that we made, that is our zero base. And if we go into what that zero base then is for a material balanced type of calculation, or when we do this cost deployment in a bit of a quicker way to at least get our total scrap levels, right? This is important to know. We want that zero level material waste, so that zero waste amount of material, because it is the baseline for our calculations. It's a bit the same as when you think of OEE, overall equipment effectiveness. If you think of the nameplate capacity or the nominal speed of the line, it is important to really determine that, define it in a good way, because it afterwards is the basis for all of your calculations. So take some time to actually get this fixed and agreed throughout your organization. So let's say we make 2 million of these cheeses. That is a million kilograms of our cheese. And well, I do know that for that you need about 10 million liters of milk, but we're going to go into the fat and protein, right? So for this production, we used 360,000 kilos or 360 tons, 1,000 tons of stuff. We used 280, and we think, wait a minute, 1 million times, this should have been 330, and that should have been 230. So here we have a loss, right? And that is the whole idea of this zero loss level. It does not yet help you to determine where it was lost, but that'll come later. It'll give you the total amount you have to calculate towards. The same as with your OEE, right? If you define that nominal speed correctly, you can just say, okay, we made so many products today. There is 24 hours in a day, so somehow we lost 6 hours. We don't know if it was a breakdown or the machine being slow or cleaning time, but we lost 6 effective hours somewhere. Now let's go hunt for them. It's an important first step. The same when you do material loss analyses, everything that is on that label, right, that is in the specifications, this is not a loss. That there, 30 tons of fat and 50 tons of protein, those are material waste, which in most companies will also be a conversion cost, right? So this is also a tricky thing, and that's why you need to be friends with your accountants and your managerial accountants. So usually when you have a material intensive type of industry, the material going in is not, well, it is a cost of course, but these are raw material costs. But be very critical, because that is the raw material cost. These here, if you can and if your accounting systems allow it, consider those as conversion cost. Because to convert that 10 million liters of milk into cheese, you spent a bit of it, you wasted a bit of that fat and protein, specifically this amount. So that is your attackable part. And that is very important information to know. The same will happen with the foil and the labels. When you have this, and then we get to the importance of not misunderstanding this zero level, we get to a value proposition, a total value for raw materials. So most of it is value added. And it's often way higher than this. If you have 50-50, expensive business. It happens, but not in process industry like cheese. So this is that 500 grams times the fat and protein on the package. That's all here. These are the real raw material costs. Then we have a level that we say, well, we just know that if you make cheese, a big part of the protein, and for the sports people among you will know this, they are the whey proteins. They go with the whey out of the cheese. That is just part of the process. You cannot do without. You can also say there are some other things, but then we get into discussions, right? So do you need the cleaning? No, not the cleaning. You never need a breakdown, but maybe some other types of conversion processes are so integral to the technology that when you use your system to change a bit, you can still say, okay, changing between two types of cheese, I need to scrap a couple of cheeses in my system. Okay, that is also going to be not in the zero level, but in the technological waste level. And the technological waste level, that's basically, we say, with these machines, with these processes, we are never going to be lower than that. So they come on top of your zero loss level, but we're never going to be able to get them out of the current process because it's in the technology. Maybe with new lines, new recipes, new whatever, we can handle it, but not asking the operators and the maintenance crew to do better. So we end up with a whole bunch of extra losses, right? But of those losses, we're not going to attack everything. So all of those, well, actually all of it is losses, but all of these are attackable losses. But when we make our planning for the next year, maybe the next 3 years, we're going to take only part of that. Only a part of the attackable losses is realistically attackable within the next year or so. So this is very important, and I see it happen all too often, that when we do a calculation like this, and then somebody higher up in management, and especially the financial sectors, they get wind of this, and they say, aha, so that's the technological level. That means that tomorrow we can produce at this level, right? And managers start putting goals to fully reduce everything that is over the guys, that is not realistic. So this here, if you get to the purple technological level, that is the same as achieving 100% OEE. Right? Think about that. We strive for it, but we're not going to achieve it because there will be some breakdowns. There needs to be some cleaning. There will be whatever, right? The 100% OEE level in material waste, that is your technological limit. We know that we might be able to engineer a machine that goes a bit faster, just as we might be able to engineer a certain recipe or new technology that has fewer waste, that can draw more of that valuable material into our product. So we get that on top of what is actually in the product. But the other waste, not everything will be immediately attackable. So we'll call it attackable because that's what it is in the long run. The same like OEE losses. But if we can just get a good chunk out of this and improve that, we are doing very well. Now, to give sort of an estimate, I would say between 10 to 20% of the attackable losses should be attackable, not solvable, with teams that you plan over about a year. So reducing between 10 and 20% of your attackable material losses year over year, that is a good, with 20 being a stretch goal, but that is a good rule of thumb to set, what are realistic expectations for a factory with a bit of a continuous improvement organization, that they do need resources to do this, to achieve within about a year. Not all the attackable losses, but still the concept is really important. The zero waste level is what is in the product at nominal weight, because if we see that we put 550 grams in the product, that is 10% overweight, no, that is in the losses, right? This is the theoretical product that we're selling with the indicated, specified ingredients that are in there. That is the zero loss level. You add on top of that those losses that with the current type of processes and machinery that they use are just inherent in the system. You really cannot do without. They should not include most of the cleaning stuff or breakdowns and stuff like that. They are theoretically solvable. Then you keep all of your attackable wastes. And of those attackable wastes, you improve somewhere between 10 to 20%. On a yearly basis. If we do that, we get a really nice improvement of your costs and keeping it more or less realistic. So I hope that this triggered lots of thought for you, gave you some good handles on how to set up your own material loss type of cost deployment, what type of ideas go into the basics, right, the outside of that box, and what to expect more from a management point of view, or what is sort of realistic. If you come up with maybe 2% of saving on the attackable losses, come on, go a bit deeper. I'm sure that you can find more options. With that, I leave you. I hope you liked it. Don't forget to hit that like button and let me know in the comments what your experiences are with this type of setting, the cost deployment, the material waste deployment, material balance. How is this done? How should this be done according to you? And for now, I just wish you the best of luck with your material loss attacking. And as always, don't forget to also enjoy the continuous improvement journey.